Alright everybody, throwing one more video in here on section 6.4. This is just kind of a review or an overview, if you will, of the endomembrane system, just to kind of a quick recap. So if we go through this, first of all, structurally parts of the endomembrane system would be the nucleus, the outer membrane of the nucleus, the rough ER here with all the dots on it, the smooth ER over here without any dots on it, and then vesicles that transport things, the Golgi complex, and then anything that buds off of the Golgi complex would also be a product of the endomembrane system. If we go through the whole process of what the endomembrane system, how it all works, it would start with, first of all, the goal is to make a protein to go somewhere or to do something. That's what the endomembrane system works with. Okay, the information for making the protein starts in the nucleus. That's the DNA. We're going to make a copy of that DNA in the form of RNA, messenger RNA. That messenger RNA has to leave the nucleus. It's going to go through one of the nuclear pores. Okay, and once it goes through one of those nuclear pores, if it's going to be a part of the endomembrane system, here we're going to make a protein, or that RNA is going to go to a ribosome that's attached to the rough ER. Okay, that way, as the ribosome makes a protein, the protein will automatically basically be engulfed by the membrane of the rough ER. Some things can happen while it's in the rough ER there. Maybe it talked about making the protein a glycoprotein, so we can add a sugar to the protein while it's in the rough ER here. And then ultimately, as it's surrounded by the membrane of the rough ER, it is going to become a part of a vesicle. So we've got a protein inside of a vesicle. Quick note, just on the structure of things here, the rough ER, the smooth ER, and the nuclear envelope, the membranes around the nucleus, they're all physically attached to each other. Those membranes run right into each other, which has some significance. But anyway, just to point that out, they are not separated. They're actually all together. So here we have our protein, maybe a glycoprotein, maybe not, surrounded by a nuclear membrane, or sorry, surrounded by a membrane, and so we call that a vesicle. From there, continuing in the endomembrane system, it is going to travel to the cis face of the Golgi bodies. Once it enters there, there's going to be an amount of processing that happens. Maybe we change the glycoprotein, maybe, or the sugar that makes it a glycoprotein. Maybe we add another carbohydrate to this. Maybe we just change the membrane that surrounds the proteins. But some sort of modifying and repackaging is going to happen in the Golgi, and then we get a whole series of things that could be produced. Okay. Regardless of what we've done to the protein, we're going to end up having part of the Golgi bud off and have the protein inside of there. Okay, maybe it's a hydrolytic enzyme that can be used for digestion, in which case this is a lysosome, and it could be used, right here's the lysosome actually, that could be used to digest something within the cell. Okay, maybe we've made a protein that this cell needs to excrete, so maybe this is a salivary cell, and we need to make a salivary amylase, which is the enzyme that breaks down sugar in your mouth. So we need to get that protein out of the cell so it can actually get to where the sugar is. So this is going to be something that this vesicle will actually join the membrane of the cell, and when it joins it, whatever's inside of it gets pushed out. Okay, so maybe that's what happens. Maybe these proteins actually have to go back and be attached to the plasma or to the rough ER or something like that. Maybe these proteins have to go and be attached to the mitochondria so they can travel there, but they're put into a vesicle so that they can travel to somewhere, wherever that happens to be. Okay, so that's our overview of the endomembrane system and how the parts just feed together, as short and concise as I could, and have a good day.